AP Problem 12, Part A says, in the boxes provided, draw the complete Lewis structure for each of the three molecules represented below. So for CF4, it's a carbon in the middle and four Fs with single bonds branching out. This way, they all fill their octet, and they all have a formal charge of 0. There's the right number of electrons and everything. For this one, PF5, it's P with 5 Fs, 5 fluorines branching off, and this way they all fill their octet. They'll have formal charge of 0. It's all good. SF4 is S with 4 Fs branching off and a lone pair. So S has 6 valence electrons, so 1, 2, 3, 4, 5, 6, and it has a formal charge of 6 here. It does go over its octet because it has, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It has 10 valence electrons, but that's okay because sulfur is in, I believe, the second period. So that is perfectly okay. And fluorine fills its octet, which is the most important thing. Okay. What is Part B says, on the basis of the Lewis structure drawn above, answer the following questions about the particular molecule indicated. What is the FCF bond in CF4? So CF4 is a tetrahedral, so it has a bond angle of 109.5. Okay, so what's the hybridization of valence orbitals in P and PF5? So P has 5 things around it, so that makes it DSP3. That's just something you memorize. And then, what is the geometric shape found by atoms in SF4? So SF4 is a seesaw. Yeah, so it kind of has 5 things around it. One of those is a lone pair, which pushes it more this way. So it's not quite like having 5 things around it. And yeah, that makes it a seesaw. Okay. 2 Lewis structures can be drawn for the OPF3 molecules as shown below. How many sigma bonds and how many pi bonds are in structure 1? So there are 4 sigma bonds. That's because the double bond, you count one of them as a sigma bond, so 1, and then 2, 3, 4, because all the single bonds are sigma. And I didn't write it, but there's 1 pi bond. That's because this double bond, the other one is a pi bond. One was sigma, one was pi. Okay. Now the next part says which one of the structures best represent a molecule of OPF3? Justify your answer in terms of formal charge. So I went ahead and assigned them formal charges. All of these have 0 because P has 5 valence electrons. Has 1, 2, 3, 4, 5, 0. This one has 7 valence electrons. 1, 2, 3, 4, 5, 6, 7. This one has 6 valence electrons. Has 6 here. Fluorine has 7, 7 here, and 7 here. So these are all 0. Then in structure 2, these 2 are 0. P is 1 because normally it's 5, and right now it has 4 around it. Fluorine is 0, and then oxygen is -1 because normally it's 6. It has 6 valence electrons, but here it has 7 around it. So this one's a -1. So ultimately it comes out to 0, having a charge of 0. However, some of them have charges. So I said that structure 1 is better because all of the atoms have a formal charge of 0. But whereas in structure 2, oxygen has a formal charge of -1 and phosphorus has a formal charge of 1. And it's best to have them have a formal charge of 0.